Okay, let's continue. Now the next up is we'll deal with one aspect of calculation, which is to do with the operator precedence and operator associativity. So at times you could have a very complicated expression in which you will have the operators of arithmetics, the logical, the relational, the identity operator. The question is, which operator has to be evaluated first? In the junior classes, you have learned a principle called BODMAS. The bracket has to be removed first, and then you have the division, multiplication, and then addition, subtraction, so on and so forth. Likewise, in computer science, there are just too many operators. So you should know which operator should be evaluated first so that you come up with the correct solution. So that is what we actually refer to as the operator precedence. Precedence means, the priority, which operator has to be evaluated first. So just as a matter of fact, I won't list all the operators. It will only add to the confusion. As per the need, I'll just come up with the common ones, which we'll be using in our lessons right now. So I'll just write something like operator precedence. Okay, I hope you got the meaning. In the first, that has to be evaluated is the bracket. The bracket needs to be resolved first. And then when you come little down, you have the exponentiation, right? So the exponentiation operator will raise the base to the exponent. You know this. Let's say if you have 2 raised to 3. Let's say if you want to find out the solution of 2 raised to 3, then you need to use the exponentiation operator, which is represented with the help of 2 asterisks. Don't call it as a star. It looks like a star, but it's not the star as a name, so it has to be asterisks, 2 asterisks, and then you have 3, so you will get the answer as 8. So even though there are many operators, but I'll just highlight those operators which we'll be using in the current chapter. So then you have this, and then after this, I think it's better if I keep it down. Okay, you have this exponentiation operator, and then you have the unary plus, unary minus. I'll just leave that aside. And then comes the rest of the arithmetic operators. Okay, you have the multiplication. I hope you're able to see. You have the float division operator, and then you have the floor division operator. Remember, okay, and then you have the modulus, which will return the remainder. So these 4 operators come next after the exponentiation operator, and then you have the plus and then the minus. Okay, and then you will have the rest of the relational operators. Okay, rest of the relational operators. Okay, so which means you have the greater than, less than, equal to, not equal to. They all will come after the plus minus, and then you have the logical operators. So the logical operator, you have 3 operators. The first one is and, or, and the not. But among these 3 operators, the first operator that will be evaluated is not, the second one is and then you have the or. I'll come up with an example, right? So when you have various kinds of operators in an expression, then which operators have to be evaluated first, will be determined by the operator precedence. In the textbook, you have just too many operators, but just focus on those operators, which we are using right now. Let's come up with some examples in order to understand this operator precedence a little better. Let's say I have 7 into 8, and then divided by 5, and then you have 2. Alright, I hope you're able to see this. Okay, now let's say I have this expression. Expression actually means it's a valid combination of the operator, the literal, and then the variables. Alright? So basically, when I say expression, I'm referring to the valid combination of the operator, the literal, and then you have the variable. This expression could be arithmetic operator. If you say arithmetic operator, then you have to have the arithmetic operators. If it's a logical expression, then you should have the logical operators. If it's a relational expression, then it should have the relational operators. So sometimes you could come up with expressions which are just mixed up, with all possible kinds of operators. So those operators are the more complicated ones. Now let's say I have something like this. Now the thing is, you have the bracket exponentiation, and then you have the multiplication, the division, the float division operator, and then you have the floor division operator. Floor means the lower integer value. But they all come on the same level. If the operators come on the same precedence level or on the same priority level, the question is which one has to be evaluated first. If it's between exponentiation and multiplication, it's straightforward. Exponentiation has to be evaluated first, followed by multiplication. But look at this expression. This expression has operators which come on the same line of the operator precedence. So whenever you have such situation, say if you have to choose between the modulus and the the multiplication sign, you need to evaluate based on the principle of associativity. Now this is the meaning of associativity. Associativity will come into the picture only when the operators which lie on the same line are mixed in an expression. Now the question is, how do you evaluate this? Okay, so you need to start from the left hand side to the right hand side. Whichever comes first from the left will have to be evaluated first. So this is the meaning of associativity, right? So this is an example in which the operators on the same line appears. If this is the case, the associativity will help us to evaluate. Whichever comes first from the left hand side, that has to be evaluated first. So coming from the left hand side to right hand side. So you have multiplication sign first. So 7 will be multiplied by 8 first. So that will be 56. 56 divided by 5. 56 divided by 5 will be like 11.2, right? 11.2. So the next will be this division sign. You have 11.2. 11.2 divided by 2. So the integer division operator, floor division operator, right? So it will be 10 point something. But since this is a floor division operator, 10 divided by 2, 5 point something, you will get the answer as 5. So we'll just do it once again. I need to start from the left hand side. The reason is they all appear on the same line of operator precedence. 7 multiplied by 8 is 56. This has to be the next. 56 divided by 5 is 11 point something, 11.2, right? And then 11.2 divided by 2. It will be 5 point something, but you will get the answer as 5.0. Okay? The reason, I hope you got the answer right. Since this is a floor division operator, it will pick up the later value. Now some of you might wonder, why not 5? Why not just 5? Why is it 5.0? We have this topic of implicit type conversion and explicit type conversion, in which the matter will be resolved. As of now, I want you to understand the operator associativity. Now let's say I come up with another example. 7 multiplied by, you have 8 divided by 5, and then you have floor division operator. Okay, let's say you have this particular example. I missed out on multiplication sign, right? Okay, now look at this. So again, you have operators like multiplication, the division operator, but you have the bracket. So the bracket has to be evaluated first. In the first example, we started from the left-hand side because there were no brackets. But this time, the innermost bracket needs to be evaluated first. So you will get 8 divided by 5. 8 divided by 5 will be like 1.6, right? It will be 1.6. Now, once I'm done with this, the next step is I have this bracket, right? So 1.6 upon dividing by 2, divided by 2, I think I missed out on one operator. Okay, 7 into, we have 2 bracket. Oh, I don't have this, right? Okay, so you know, this will be 1.6. Now this is the next up. Okay, since I have the bracket needs to be resolved. All right. So 1.6 divided by 2. Okay, you will get 0 point something, right? 0 point something. But you know, since this is a floor division operator, it will come out with a lower integer value, which got to be 0. So when you multiply 0, then comes the multiplication operator. Okay, so 7 multiplied by 0, it will be 0.0. Okay, so now here there is a shuffle in the order. The reason is I have the brackets, and the brackets need to be resolved first, right? Hence there is a shuffle, so you have a different answer, right? So let's take one more example. 7 multiplied by, let's say you have 8, and then you have 5, and then you have 2, right? 7, how come I have 2 asterisks? Okay, 7 multiplied by 8 divided by, okay, okay, now let's say I have this question. Now again, the innermost will have to be evaluated first, right? So 5 divided by 2, you will have the 2.5, but since this is floor division operator, you will get the answer as 2. Integer 2. 8 divided by 2, it will be 4. 4 multiplied by 7, it will be 28, right? So this is how, you know, you should be resolving the expression, you know, which have, you know, the operators. Okay, I hope you're clear with this. But there is one exception. Let's say if I have something like this. Okay, let's say I have an expression like this. Okay, 1, 2, and 3. Now you have 2 exponentiation operator. Now this is the only exception. Whenever you have 2 exponentiation operator, the associativity will start from the right to the left. Unlike the earlier example of these operators where the associativity will run from left to right, but over here, you know, it has to move from right to left, which means should 1 raised to 2 be evaluated first or 2 raised to 3? So this moving from the right to left, you know, this has to be evaluated first. So 2 raised to 3 is 8, right? 2 raised to 3 is 8, and then 1 raised to 8 is 1. So you will get the answer as 1, right? So however, if I use the bracket, to evaluate 1 raised to 2 first, let's say I have something like this. Okay, 1 raised to 2, right? So again, the answer will be pretty much the same, is it? Okay, let's say, okay, I still get the answer as C. Now let's say if I come up with another example where, you know, the answer will be a little different. Let's say I have 1, or just to play safe, I'll come up with 2, 3, and then I'll have 4, right? Now let's say I run like this. So when I run it, you know, you get this big number. Okay, so however, if I enclose 2, I do this first, and then, I have this, I'll get a different answer, right? So this clearly shows that whenever you have this expression, it will start from right to left, okay? You could try with smaller numbers, but make sure that you come out with the different answers, otherwise you will not get it. So when I enclose this, 2 raised to 3 will be 8, 8 raised to 4 will be 4096. 3 raised to 4 is already a big number, and then when you have this as exponent for this, it will even be a larger number, right? Okay, so this is the difference between the two, okay? Now, next up is, let's move on the next topic, how to evaluate the relational expression, right? Now let's say I come up with the next topic. Okay, let's say how to evaluate, how to evaluate the relational expression, right? Okay, so again, this is pretty simple. Now let's say you have a situation like 2 greater than 1, okay, and then greater than 0. So this is again one, unique feature which is available in Python, right? Otherwise, the major chunk of the ones which I've shown you earlier are replicated in the other programming languages. But there are a few which are unique to the Python programming language, and this is one such feature. So you can chain the multiple comparison in the Python programming language. You can chain means you can combine multiple comparison. You have 2 comparisons here, 2 raised to 2 is greater than 1 and 1 is greater than 0. So when I press enter, I get the answer as true. Now this is equivalent internally, this is equivalent to 2 raised to 1 and 1 is greater than 0. So I want everybody to get this. In Python you can chain multiple comparison, but this is internally interpreted as 2 greater than 1 and 1 greater than 0. So unless and until both the conditions are true, the result will not be true. So when you press enter again, it works out to be, the same, right? So this, for example, if I come up with another example, say 4 greater than 3, and then 3 less than 1. So again, this is true. 4 is greater than 1, and 3 is less than 1. Again, it's true. However, so when I press enter, I'll get the answer as false. Right, because the 3 is not less than 1, sorry. Okay, so this is, now why do you get the result as false is, even though this is true, but this is false. So this is equal to 4 greater than 3 and 3 less than 1, right? So this is how you evaluate the relational operator with chain of multiple comparisons, right? And then the next step is, again, there is another way of evaluating the logical expression, okay? So this is now these are bits and pieces, if you know how to understand the working, that's more than enough. Now let's say you have the logical expression. I'll come up with an example. Let's say I have something like 25 divided by 5 or 2.0 plus 20 divided by 10. Now let's say you have this expression which involves the arithmetic operators, okay, and then you have the logical operator. Remember, as per the precedence level, the logical operators come much further down as compared to the arithmetic operators. So it's understandable that I need to evaluate all these first, right? So you have 2 different expressions, right? One on the left of OR and one on the right of OR. So when you evaluate this, 25 will be divided by 5, you will get the answer as 5.0. It's not just 5, it's 5.0. 5 means it's an integer literal, 5.0 means it's a floating point literal. So you'll get 5.0. And then among these, this will be evaluated first. Remember, the division operator comes before the addition operator. So this will be evaluated first. So what do you have? 20 divided by 10 is 2. Alright? So it is 2.0, right? So 2.0 plus 2.0 is 4.0. So you have 5.0 or 4.0. So when you have OR operator in between the operands, so remember the rule. If the first operand has a true value, the first operand will be the result of the expression. So you have 5.0 as the first operand, 4.0 as the second operand. So when you have 5.0 or 4.0, 5.0 has the truthfulness value of true. If it's true, the first operand will be the result. This is the reason why you get the answer as 5.0. Okay, so let's check another example of how to evaluate the logical expression, right? So let's say I've copied the example here. Say 5 less than 10. Okay, and then you have and 10 less than 5 or 3 less than 18 and not 8 less than 18, right? So again, you have the series of logical operators like and, or, and not. So these are the first the expression that need to be evaluated thanks to the bracket, right? So just evaluate the expression which are enclosed in bracket, okay? So you will have this is true, okay? Just go on. Now, once you are done with this will be like true, this will be false, this will be true, this will be true, this will also be true. Now, once we are done with evaluation of the ultimate rational expression, look at it, even if you do not have the bracket, the relational comes before the logical operators, right? So once you're done with evaluation of all these, now you have and, or, and not. The question is which one of these logical operators need to be evaluated first, right? So that's when this comes into the picture. You should always start with not, and then and then or. So the operator's precedence among the logical operators will start with not, and then or. So this is the first one that needs to be resolved first. So 8 less than 18 is true. Okay, so not of true is false. So you have false, okay, and then now the next step is and. Remember, so you have either you could resolve these two, okay, or you can resolve these two. So okay, we'll try this first. This is true, this is false. True and false will be false. So the overall result of this will be false. Okay, false. Alright, just keep in your mind. And then you have, just check out this. Now next up is the and, right? Again, it will be and. 3 less than 18. Sorry. Just change this to. Okay, 3 less than 18 is true. But remember, this was true, but because of this, it has changed to false. So true and false will be false. Alright? So you have false here on the left side of the OR, and then you have false also on the right side of the OR. So when you have false or false, if Tencent, let's say if I want to see Tencent or sitting, if both do not turn up, the answer should be false. I won't be happy, right? So when you press enter, you should get the answer as false. So this is how you have various means by which you could actually evaluate the various kinds of expression like logical, arithmetic, or relational, right? So I think think it's better to stop here because the other topic, the next topic will easily take like 20 more minutes, and that will make the video duration very lengthy, right? So with this, I would like to wind up. I hope you have understood. And then don't worry, I'll be giving you the notes of this particular chapter. So as and when you watch the video, try to refer to the notes, and that will make the understanding process much easier, right? So thank you and take care.